Hey Chemsters, this is Mrs. Vanley bringing you another edition of the Chemster videos. We continue off from the chemical predictions and we're on single replacement. If you were listening to the last one, I meant to cut off and I didn't, so it may have carried on, but if you watched your instructions, you were to stop at a certain time. And I'm going to kind of repeat what I did at the very end of the last one. So anyway, here's the single replacement, and this is where you have an element and an ionic compound. And I had told you earlier that there may be times when there's no reaction because in this case, the nonmetal or perhaps the metal is always going to end up with the one that is most active or most reactive. So you need a chart that is actually found on Google Classroom. So if you would, let's go to Google Classroom. And here you see this chemical predictions flipped classroom. And right here, if you want to click on this, you will see that there's an activity series and solubility table. So go ahead and click on that. So I'll go ahead and pause if you're not caught up yet. So get to that page, and if you need to pause, go right ahead. So pause this. So you'll need to scroll down, and this is the second page of that handout. And this is called the activity series of metals and halogens, halides for single replacement reactions only. Okay? And so this is the table that you will have access to on any test. Okay? So you'll have a hard copy. You'll get a hard copy of this next time we meet too. And just take a look at this and go back in your memory banks. And when we're in chapter 6, the periodic table, one of the last things that we did there was talk about the activity of these different metals. And we concluded that group 1 is more reactive than group 2, which is more reactive than your transition metals, which are more reactive than your precious metals, your gold, your silver, your platinum. And notice that that is a similar trend here. What are your first two elements up here? It's potassium and sodium, isn't it? Actually, lithium would be right up there too if it were included in this activity series. What follows this is calcium, magnesium. Those are your group 2 metals. Notice what's on top. Potassium's higher than calcium. Okay, group 1 is higher than group 2. And then you have aluminum, which is fairly reactive. And what do you notice down here? Here's your zinc, iron, tin, lead. What do they have in common? They're all your transition metals. We didn't include hydrogen in our discussion back in chapter 6, but this is where hydrogen will be. And notice what's pretty much at the bottom. Here are your precious metals. Okay, so this is a very, very similar trend to what we learned in chapter 6. Notice how, our past knowledge is going to help us here. Look over on this section too. We talked about your non-metal reactivities. We said your halogens, your group 17, were going to be more reactive than your group 16, which is oxygen and sulfur, which is more reactive than your group 15. And from that series, we said fluorine is going to be the most reactive of all your halogens. Do you remember why that is? If you said it was the more electronegative element, it's the most electronegative element, you'd be right. It wants those electrons from anything else. It's going to grab them from whatever is out there. So it is the most reactive of your halogens. So this is consistent with what we learned earlier. And then if you look at the bottom half of this page, all right, you're going to see where the same format again, that these are going to react with water, these will react with acids, these will react with oxygen, and down here is your silver, your gold. Very, very unreactive. And if you think about it, why does that make sense? What happened in the history, like when the Spanish Armada sank? Didn't they have lots of gold doubloons or something in their treasure chests? And hundreds of years later, we can dig up those gold coins, and they're still gold. Why? Because they're so unreactive that they're not going to dissolve or do something in the water and make hydroxide. They're not going to do anything like that. They're going to remain as gold. They are unreactive. But But if you had coins made out of potassium, you'd never have any money. It'd always be reacting in your pocket and maybe start your pocket on fire or something, all right? So bad choice to make coins out of potassium, wouldn't it? So have this chart handy. Maybe you can do a split screen so that you can refer to this easily as you're going through these notes. Again, next time I see you, you will get a hard copy of this, but bear with me for now, okay? So have access to this as we continue on in our notes. So let me go back to the note page. Here we are. All right, so we need to look up on the activity series. That was the page you just saw. And this is again where you have, in this case, a metal replacing the other metal. The A and the B swap. C ends up with a metal no matter what. Okay, C will end up with the most active or the most reactive metal no matter what. So you need to compare those activity series and which one will be the most active, okay? So the element higher up, so on your chart it will be potassium, will be the more attractive. It will always replace the element below it. Metals replace metals, non-metals replace non-metals. So in the case of the first one, lithium and silver, hang on a second. Okay, what you need to do is say, all right, you have a metal here and a metal and a non-metal. So it's the two metals that are in competition. So go back and look at your activity series, the page that we just saw, and try to find, well, Mrs. Vanderway, lithium is not there. Okay, you're right. I have a different table where it would be on there. But still use what we learned in Chapter 6. Lithium is a group 1 metal, isn't it? Yes, silver is a precious metal. So even though lithium's not on that particular chart, hopefully you know in your heart of hearts that lithium will be more active than silver. Group 1 is more active than a precious. So there will be a reaction. So flip your lithium and your silver around. So now lithium ends up with chlorine. So what do you have to consider now is, oh, they're charges again. What is the charge of lithium? Lithium is +1, right? Chlorine is -1. So what will be the formula of lithium chloride? It will be LiCl. Hey, the charges canceled. That was pretty handy. And then what is left all by itself is your silver. Silver will be plated out. Do you remember from that lab that we did where you put the silver nitrate on the copper? Remember that? And if you let it sit for a while, you saw these little fuzzy things on the copper. Well, what were those little fuzzy things? It was pure silver plating out. Hey, maybe you can get rich, okay? That was your pure silver. And so a very similar reaction would account here. So what do you have to do next? Finally, you have to balance it, and guess what? It already is balanced, okay? What about the next one? What if I were to flip-flop it? What if I had pure silver and I put lithium chloride on the pure silver like what we did in lab? Well, go back and look at your chart. Where is silver? Where is lithium? Well, lithium's on the top. Silver is towards the bottom. Well, what's going to happen here? Chlorine will always be with the most active metal. And guess what? It already is with the most active metal. So is anything going to happen? The answer is no, no reaction. So there was one of these examples on your lab, and you're like, Mrs. Vanderway, nothing's happening. I'm like, is that okay? And the answer is yes, it's fine, because if you go back and look, that the most reactive, or excuse me, most active metal is already with the non-metal. So no, nothing's going to happen. Okay, so no reaction. All right, well, how about the next one? Well, what's different about number 3 is that you have as an element a non-metal. So now you have to compare the non-metal chlorine with the non-metal fluorine. And which one is higher up? If you have to go back and look at that chart, which one is higher up? It's fluorine. So keep in mind your sodium will always be with the most reactive non-metal, in this case is fluorine. So is there a reaction? And your answer is yes, there is. So now we have to come up with our products. Once again, you have to do this. oh, we have a +1 and a -1. So what is the formula for sodium fluoride? Is NaF. The charges cancel. And let me just tell you from all my years of experience, and that's a lot of years, longer than all of you've been born, this is where people are going to make boo-boos. They're going to see the F2 here, and they're going to want to make the NaF2. Well, it's F2 over on the other side, but that is not how you determine the ionic formulas, all right? So let me erase that. So it is not NaF2 because that would be like too convenient, wouldn't it? It's NaF, okay? You must look at the charges, okay? And what element is booted out? It is your chlorine. So it is now by itself. And what's left to do here, let me erase what I've done over here. What's left to do, we have to balance it, don't we? So if you go back and look, hopefully, well, we have one sodium, one chlorine, two chlorines, put a 2 here and a 2 here, and now your fluorines are balanced. So go ahead and look at the very next one. Decide what is in competition, look it up, and determine what your products are. Well, hopefully you said no reaction. Why is that? What is higher up on the activity series of your nonmetals? Bromine is. So calcium is already with bromine, therefore it's not going to swap out with iodine. It's going to stay with the bromine, so no reaction. All right, so let's see what's going on. Now notice in the activity series, hydrogen was there. And I've kind of implied earlier that think of water as hydrogen hydroxide. So the quote metal is going to be hydrogen. The non-metal is going to be the hydroxide. And so what are you going to make? You're going to make hydroxides with single replacement and water. Note the hydrogen is acting like a metal. It is on your list, okay? So the hydroxide is going to end up with the most active metal. So look at potassium and look at hydrogen. What are you going to make? Oh, you're going to make potassium hydroxide. So once again, what do you have to consider are the charges. Potassium's a +1. All hydroxides are -1. So what's the formula for potassium hydroxide? I hope you got that. Now what? What is booted out? What has been replaced by the potassium? It's hydrogen. So do you put +H? No. Hydrogen is a Hofbrinkel. It's a diatomic. So it's +H2. So now what do you have to do? You have to balance it. Is there something that you should wait to the end? Probably the H's. So I have one potassium, one oxygen, one oxygen. Well, that didn't help. So do you remember back when we did the combustion, we talked about the even and the odds? I have an odd number of hydrogens here, but I'll always have an even number of hydrogens here. So I need to make an even number. So I'm going to put a 2 out in front to get an even number of hydrogens. And I think if you put a 2 here and then a 2 here, it will all work out. Okay? So try number 6. Think of water as hydrogen hydroxide and look them up. Well, what did you notice when you looked it up? Which is higher up, the hydrogen or the silver? Look it up. Oh, the hydrogen's higher up than silver. Yes, silver is a precious metal. So if I put silver in water, nothing's going to happen. It's going to do nothing. I'm not going to see a color change. I'm not going to see any bubbles. I'm not going to get any heat. I'm going to get nothing. All right, it's just going to sit there. Okay, but what about the next one? What about calcium and nitric acid? So which one is higher up? Go ahead and check that out. If you said calcium is higher up than hydrogen, you are correct. So now we need to make the swap. So calcium and nitrate are now going to hook up. And again, you're going to have an ionic situation. So you have to look up the charges. Well, what's the charge of calcium? +2. What's the charge of nitrate? Oh my goodness, you have to know that one, don't you? Do the charges cancel? Not in this case, so you have to crisscross. So when you crisscross, this is what you get. Okay? Now what? What's been replaced? What is now by itself? Well, once again, it is hydrogen. Okay? And finally, what you need to do is balance it. Go ahead and balance this. Did you get a 2 here? Hopefully that works for you. Go ahead and do number 8 all by yourself. Pause this. Is this what you got? Which is higher up? Is barium higher up or is zinc higher up? Well, barium wasn't on your list, I don't think. Barium's not on your list, all right, so what are you supposed to do? Well, what did I imply last time? That barium is a group 2 metal, and your zinc is right here underneath group 2 in aluminum. So barium is the higher metal. So now the question is, did I do this right? Is barium going to get booted out if barium's already the more active metal? The answer is no, it's not. So I hope you didn't do that. You get no reaction. Okay, because barium is actually higher than zinc. No reaction. Okay, does that make sense? I hope so. Go ahead and do number 9. Oh, pause this. All right, so let's check out that activity series. Hey, guess what? Tin is on the list. Is tin higher than hydrogen? The answer is yes, it is. So tin is higher than hydrogen, so tin is going to end up with a chlorine and hydrogen is going to get booted out. Now, why did I pick tin plus 2? Remember I told you earlier, if you have a choice, pick the plus 2, and tin isn't one of those exceptions. You could have picked also 0.4 or plus 4, but you know, make it easy on yourself, make it a 2. And so what's left to do at this point? We need to balance it. So put a 2 right here, and now you're done. And this is going to be the end of the flipped classroom, and I hope you found it helpful. If you had any questions, write it down, and we'll do some practice problems the next time we meet. So don't wait to be great.